we are going to do a benzylic radical halogenation, getting ready for our final exam here. And we are told in the title that we need to do 1 initiation and 2 propagation steps. And we'll do it down here. Initiation, the halogen breaks in half. Got to have the hooks or you don't get the point. Show me the hooks. And you remember when it cleaves in half like that, it's called homolysis. You have equal splitting of a bond. Generate chlorine radical. Chlorine radical. Oh, there's a typo. It's not a typo. When I did this, I copy pasted and forgot to edit. The product is HCl, right? Just going to go to the top of the screen and fix that too. The product is HCl. Not ClCl. That's not, whoa, hello. Come on. My goodness. Okay, here we go. Next up, we got to make HCl. P1. Cl dots, got to get an H from somewhere. It's from the benzylic position. Remember, benzylic is a carbon, 1 away from benzene. That definitely qualifies right there. It makes very stable radicals. They can resonate with the benzene. That's why the numbers are so low for breaking this bond. And yes, there's your HCl, as promised, and your benzylic radical. In this case, a secondary benzylic radical. If you had to give it a stability number, you'd say 3.5 degrees of stability. I mean, it's not required on this test to tell me it's secondary benzylic. It's not required on the test to tell me that's about the same as a 3.5 degree radical. But it's good to know for other parts of the exam, isn't it? And then prop 2. Take that radical you just made. I flipped it over, no big deal. May have even resonated the benzene accidentally, no big deal. It's the same radical. Hook it up with the chlorine. Make sure you have both those hooks over here starting in the middle of the bond. I see some students, they start one of the hooks for some reason. It's a consistent thing. I see 3 or 4 students every semester. They start one of these hooks at an atom. Guys, we don't start hooks at atoms ever. We start them at lone pairs or bonds. Okay? That's the only 2 places to start an arrow or a hook, at a lone pair or a bond. And they end, hooks can end together, which means make a bond, or they can end on an atom, which means make a radical. And you're finished with this mechanism. You get, oh, I rotated it a bit. That's my natural way of drawing these. Cl there. And chlorine radical, which cycles back to propagation step 1, doesn't it? There you go. And that's all we have for that. That's about a 6-point mechanism right there, too. See you on the other side.